We have an example. We need to apply problem solving steps. We need just to read. Then we need to find the parameters or the quantities. What are the knowns? What are the unknowns? After organizing them, we need to know which equation we need to use. We have 3-4 equations. They are here with us. Which one we will use? Then start, put our values in our equation, and that's it. We need to find the result. Then we need to discuss that result. Okay. For this equation, scalar moving regular speed. So we have V initial is equal to 1.75 meters per second. Began to climb up a hill, has a move, slowed down with acceleration. A is equal to -2 meters per second. It is deceleration. Okay. And skater settled at level B final. Find the time spent for this process. We have this experiment, and we have a starting portion here. And we start with V initially and stop at this point. How much V can find? When I am telling you in the question that he stopped at this point. How much is velocity here? It should be known. It is given. If I am at stationary now, how much my velocity? Yes, tell me. Okay, my velocity when I am standing up, standing without any motion, my velocity is 0. So my velocity here, 1.75. My velocity here is 0. My acceleration is negative. Which equation of them I need to use to find the time? If I look to that, I will put them here. V2 is equal to V1 plus AT. V2 squared is equal to V1 squared plus 2AX. X is equal to X naught plus V naught T plus half AT squared. I have the time in the first and the third one. If I need to use the third one, I don't have the displacement, which is X. My X now has a slope. It is not horizontal. What about the second one? I cannot find the time from the second one. What about the first one? Yes, it is direct. I can apply V2 0 is equal to V1 1.75 plus the acceleration -2, use parentheses, multiplied by the time. I can move one of these terms to the other side. So, for example, if you like to move this one, it will be -1.75 is equal to -2 3. The negative can be cancelled with the negative. I can divide over 2. Then the time will be equal to this over this. It will be 1, 5. I'm not doing calculations. It will be 0.8. Tell me please. 1215. 125 seconds. I will divide it. 1.75 over 2. 8. 75. Okay. This is the time. What if I ask you how much the displacement? You can use now the second or the third. Okay. You can find it. Any question about this example? We have the next example. We need to use the second equation. If you remember the previous pages, you have the formulas. You need just to put the value in f of x to find the final value. Just to substitute your values. Just it's the same thing. We have relations, we have values. What if we have the acceleration? Page number 31 is equal to 1 meter per second. And we have v final 7.5 with its units. And d, which is equal to the position change, which is 19 meters. Just meters. What is v initial? Using just second equation. I ask you about v2, v initial, I'm sorry. If you use the first one, you don't have the time. The second one, you have the position, the acceleration. V2 is given, V1, you need to find. Just like that. So, V2 squared is equal to V1 squared plus 2ax. V2, which is V final, square it. (7.5) squared is equal to V1 squared plus 2. The acceleration is 1. The change in position is 19. Reorganize them. You will find that V1 squared is equal to this minus that, which is 7.5 squared 5.6.25 minus this, which is 38, is equal to 18.25. This is meter per second, right? Because this is velocity. This is velocity squared. This is meter per second. All of them are squared. We need to find the square root. So V1, which is square root of this, it is 4.27 meters per second. Solve it again by yourself, please. We have in page 32 also another example using the third equation. And you have boxes just to put your variables in these boxes. Page 33 also you have another question. You can solve it. Aha. That's good. Any question about the constant acceleration relations? If you see now, if you know, we use x because we are moving in the horizontal direction. Some of you will ask, what if we move in y direction? Just we can change from x to y. What is our example? It is the motion, this motion. The motion in y direction. We will study now the free-falling body. It is a body formed with its by its